Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. So, in this video, we will be looking at two main concepts. The first one is substituting constants in f of x. Now, part of this type of question we've already covered in our previous video when we were calculating the range from given domain. Okay, so this would be just a quick revision for you. And then there will be a second topic as well. So, as we'll move along, I'll let you know what that is. Okay, so substituting constants in f of x. You know that f of x is an equation which is in terms of x. The x values are the domain values. Okay, so whatever value of x you plug in, you will get an output. So remember, we studied in our very first lecture that a function is kind of like a machine. So you plug in something, and that something is x value, you get an output which is a y value. Okay, so let's take an example. F of x is equal to 2x plus 2. Find out what will be f of 2. Now this f of 2 means that instead of x, now I'm giving you a specific value that what x should be, and that value of x is 2. So what's going to happen if I plug in 2 instead of this x? So this is what's going to happen. Over here, first of all, I'm going to write 2. Okay, also you have to make sure that you use that correct notation. So now you're not going to write f of x, you're going to write f of 2. So that means instead of x, I'm plugging in the value 2. So in my equation, the 2 comes here in place of x, and therefore now you just work out the value. What will be the corresponding y value? So that will be 2 times 2, which is 4, and 4 plus 2 is 6. That's it. Okay, and you can say that this is one value of a range. So this value of domain will be mapped onto this value of the range. The next one is f of 0. Okay, that means that now instead of x, we have to plug in the value 0. So that would be 2 times 0 plus 2. So this becomes 0. So you'll be left with just 2. Number 3, f of minus 4. So now here you have to plug in the value of minus 4. So we're going to write minus 4 over here, and we're going to write minus 4 over here in both of these. Okay, so now 2 times minus 4, that would be minus 8 plus 2, which is minus 6. After that, f of half. Okay, so now this half would be written over here as well as over here. Okay, so therefore, now we can see 2 multiplied by half, 2 and 2 will cancel out. You'll be left with just 1. 1 plus 2 is equal to 3. Then number 5, f of minus 3 upon 2. So plug in the value of minus 3 upon 2 in place of x over here and x over here. So that's what we've done here. So this 2 again cancels with this 2, and now you're left with minus 3 plus 2, which is equal to minus 1. The last one is f of 0.4. Okay, so we plug in the value 0.4 over here and over here. So 2 times 0.4 is 0.8. 0.8 plus 2, that gives us 2.8. Okay, so let's move to example 2. Now you have a function g of x equals to 3x squared minus 5. Find g of 5. Okay, that's the first one. So again, although here now we have a quadratic equation, over here we had a linear equation. Okay, but the main idea, the main concept is the same. So if I want to find out what is g of 5, I'm going to substitute 5 over here as well as over here. So this is what we're going to write down. 5 comes here and 5 comes here. Now 5 square will be 25 multiplied by 3, that is 75, minus 5, that is equals to 70. Okay, all right, second one is g of 0. So 0 comes over here and it comes over here. So this whole term becomes 0. You'll be left with just minus 5. Number 3, g of minus 2. So here you have to substitute minus 2. So 3 times minus 2 whole square minus 5. The square of minus 2 will be 4. Then 3 times 4 is 12. and 12 minus 5 is 7. That's the answer. Part 4 is g of minus 5. So now we plug in the value minus 5 over here and minus 5 over here. So square of minus 5, that is 25. 3 times 25 is 75, minus 5 equals to 70. Now you can see in the first example we plugged in the value 5, and in the second example we plugged in the value minus 5. So why do we get the same value in the range? Because this is a many to one function. This is a quadratic function. So for two values of x, you're going to get the same value of y. So remember that a quadratic curve looks something like this. So for two values of x, you can have the same value of y. This is your y value, and you had two same values of x. Okay, so let me just quickly draw this. So that means this could be 5, this could be minus 5, and over here you have same value of y for both of them. Okay, all right. Number 5 is g of root 3. So here we have to plug in root 3. So the square of root 3 is going to be just 3, because a square and square root cancels out. So 3 times 3 is 9, 9 minus 5 is 4. Then we have g of minus 1 upon 3. So we plug in the value of minus 1 upon 3. So the square of minus 1 upon 3 is 1 upon 9. Then this 3 cancels with this 9. So here you have 3 left. So 1 over 3 minus 5. That gives us minus 14 upon 3. That was example number 2. Now, you have another example where we have an exponential function. Okay. So here we have h of x equals 4 to the power of x. So let's see. Here we'll try different values. So when we plug in the value of 1, so this 1 will be substituted over here and it will be substituted over here. So therefore this becomes h of 1 equals 4 to the power 1, that is equal to 4. The second one is h of 0. So you plug in the value of 0 over here, plug in the value of 0 over here. Anything to the power of 0 is equal to 1. So that's why you get 1 over here. Number 3, h of 2. So that means h of 2 equals 4 square, which is equal to 16. Part 4 is h of 3. So h of 3 will be 4 cubed, which is equal to 64. Then h of minus 1, you plug in the value of minus 1. Now when we have a power as minus 1, we take reciprocal so that the power becomes positive. Okay, so we studied this in our indices, the chapter that we covered on indices and also algebraic indices. Okay. Then similarly, we have the last one, h of 1 upon 2. So you plug in the value of 1 upon 2. Now 4 to the power 1 upon 2 is another way of saying square root of 4. Okay, so if let's say I have 4 to the power 1 upon 3, that would mean cube root of 4 and so on. So therefore square root of 4 is going to be equal to 2. All right, so this is where we substitute constants into the in place of x. Okay, so instead of x, now we are giving specific values to our x. But what if I'm not giving them constants, but I'm giving them variables? Like for example, here my equation is 4 to the power of x. What if I give it x plus 1? So that means this x plus 1 is now going to substitute this x. So I'm going to have, so this is what I'm going to write down. H of x plus 1 is equal to 4 to the power of x plus 1. Same concept. Okay, just the difference is that instead of constants, now I'm plugging in the variables. And that is what our next topic is about. Substituting variables in f of x. So similar to constants, variables like x, 2x, 3x plus 1, okay, or anything or something that is subtracted like 5x minus 4 and so on, can be substituted into a given function. Okay, so again, let us take an example. F of x is equal to 2x plus 1. This is the function which is given to you. Find in simplest form f of 3x. Now you see the question has just been slightly modified, because obviously you're not going to get an exact value. I mean, you're not going to get a numerical value, but you're going to get an algebraic expression. So what you have to do here is that once you have substituted this, you need to find your answer in simplest form. So f of 3x means that now instead of x over here and x over here, I'm going to write 3x in both of them. Okay, so f of 3x is equal to 2 times 3x plus 1. So 2 times 3x means 6x plus 1. That's it. Same exact concept. The only difference is that now you're substituting variables. Let's take a look at second one. F of x plus 1. So this x plus 1 will be written over here as well as over here. So f of x plus 1 equals 2 times x plus 1 plus 1. So 2 times x, that is 2x, 2 times 1, that is 2, and then we have this one over here. So 2x plus 2 plus 1, these are like terms, so we add them, this becomes 3. So 2x plus 3 is the answer. Number 3, f of 2x minus 3. So 2x minus 3 is what we're going to substitute. So this becomes 2 times 2x minus 3 and then plus 1. So this 2 multiplies with this 2x and then multiplies with minus 3. Make sure that you take this minus sign into account. So we get 4x minus 6 plus 1. So this becomes 4x minus 5. Number 4, f of x upon 2. So here we are going to plug in x upon 2. This 2 cancels with this 2. So you are left with x plus 1. Then we have x over 4 plus 1. So now multiply again individually. So 2 times x over 4. This means this 2 and this 4, they cancel. So you get x upon 2. So therefore you have x over 2 over here. Then this 2 multiplies with this 1, so you get 2. And then you have this 1 over here. So you see, one thing that you must remember is that after substitution of the variable, okay, after substituting the variable into this x, do not forget to write the remaining part of the function. Because sometimes students, what they do is, like for example, this is a different variable which we are substituting. This is a different expression altogether. So we are substituting and we are putting an expression into the function. So once they write this plus 1, they forgot to write the original plus the plus 1 of the original function, the remaining part of the function. So this you should not forget. Okay, so therefore the final answer is going to be x over 2 plus 3. Now example 2, so here we have a quadratic function. The same concept is going to apply over here. So let's try g of 2x. So we are going to plug in 2x instead of x. And then I'm going to take whole square of this 2x. Okay, like this. So you see, all that we are doing is the blue part is the original function. Red is what we are substituting. So I'm only substituting 2x instead of x. Therefore, this whole square is still intact. Okay, there has no effect on that. So 2x whole square means square of 2 and square of x. So that would be 4x square. 3 times 4x square would be 12x square minus 4. The next one is x upon 4. So g of x upon 4. So x upon 4 whole square, that would be x square upon 16. Then we have 3 multiplied to this because there can be no simplification into the of this, right? So 3x square over 16 minus 4. Number 3, g of root 2x. So I'm going to plug in root 2x over here. So this root and this square, they cancel each other. So we are left with 3 times 2x, that is 6x minus 4. Okay, now if you look over here in part 4, this is slightly different. Okay, it says g of 3x and then you have to add 4 as well. Okay, first you have to write g of 3x. So I'm going to write this 3x over here and I'm going to write 3x over here. The rest of the expression will still be written as it is. So here we go. I've written 3x over here, and until this portion, this is the original function. Okay, so forget about this 4 over here for a moment. Your original function is g of x is equal to 3x square minus 4. So all I have done is that I have plugged in 3x square, sorry, 3x into this side. So that's what you have over here. Then the question also asks you to add 4 into it as well. So that's what we have done at the end. Okay, so this is the requirement of the question, that you have to add 4 as well. So therefore now you simplify. So 3x whole square will be 9x square, okay, being multiplied by 3. This minus 4 and this 4, they cancel each other. 4 minus 4 is 0. So you will be left with 27x square. Okay, then the last one, sorry, the second last is g of x minus 1. So we substitute x minus 1. Now here what we have to do is, because now this is the expansion of the bracket of x minus 1, so here we are going to expand it. So this x multiplied by x and multiplied by minus 1, so you get x square minus x. Then this minus 1 multiplies with this x and then multiplies with minus 1. So you get minus x, and minus 1 times minus 1, that is plus 1. So when you add them up, simplify, you get x square minus 2x plus 1. So now this is going to be the answer to this part of your question. So therefore, this part has now been replaced in green. So you have 3 times this whole bracket, and then we have minus 4, expand the bracket, so you get 3x squared minus 6x plus 3 minus 4. Collect the like terms, okay? So this is going to be your final answer. And then lastly, we have 2x plus 1. So again, I'm going to substitute 2x plus 1 over here, and then we're going to expand the bracket at the bottom. So 2x multiplies with 2x and then multiplies with 1. So you get 4x squared plus 4x. Sorry, my bad. This should be 2x, right? So we have 2x times 1. So that would be 2x. Then we have 1 multiplied by 2x. Again, that is 2x. Okay, so the final answer should be 4x. Okay, so let me substitute this over here. So this is going to be 4x. And okay, so 3 times 4x squared, that is 12x squared. 3 times 4x, now this becomes 12x. Okay, now this is correct. So this 3 times 4x squared, and then this 3 times 4x, and then this 3 times 1. So this is all that you get, and then you write minus 4 at the end. Okay, finally this is going to be your answer. Make sure that when you're working this, you show every single step throughout your working. Okay, so that is the end of this lecture. So I'll see you in the next video, where we will start solving some past paper questions related to this topic.